Okay, so yes, so those of you that are listening now, some of you I know zone out or have other things to do. Happy Wednesday. Tomorrow's Thursday, which kind of feels like tomorrow's a Friday because we don't have school this Friday. Spring break starts this Friday. So let's go over what we talked about yesterday. Again, when you add or subtract monomials, when you add or subtract terms, exponents do not change. When you add or subtract, exponents do not change. Okay? You just combine like terms. So something like this, if I have 9x squared y minus 10x squared y, it becomes negative 1x squared y. Exponents do not change. Okay? All right, then we talked about the first rule called the product rule. We multiply with the same base. So when I multiply and we have the same base, and remember what the base is just that big number. Right? We multiply and we have the same base. What do we do to the exponents? We just add the exponents. And we talked about why yesterday, because in this example, if I have h squared, that's just h times h, and h to the 6 is 6 h's. And since I'm multiplying them, it's just all being multiplied, and we're multiplying the same thing 8 times, so that's h to the 8th. Or just add 2 plus 6. Okay, and then we had this problem where we're multiplying two monomials, we're multiplying two terms, so we just multiply the numbers together, we multiply the a's together, and we multiply the b's together. Next, we learned the power rule. So now we only have one base. If you notice here, we only have one base to a power, but then that whole thing is raised to another power. So we have power to a power. So what do we do to those exponents? What's the shortcut? The shortcut is just to multiply them. And why? Because if we look at this example, x squared to the third, well, x squared to the third means I have x squared 3 times. And so x squared is 2x's, x squared is 2x's, x squared is 2x's. So if I have x squared 3 times, that means I have x to the 6th. I have 6 x's. Because I have x squared, x to the 2nd, 3 times. So you multiply them. All right, next is the quotient rule. So when I divide the same base, what do I do to the exponents? We said we subtract, right? The top one goes first, bottom one goes second. So it's top minus bottom. Why do we do that? Well, because we're going to cancel out. If I have 5 x's up here and 1 x down here, right? I have 5 x's up here and 1 x down here. These are going to cancel out because x over x equals 1. So we can multiply. We're multiplying by 1. We can cancel it out, cross it out. And so we're left with 4. So that's why we subtract bottom minus top exponent. And then we tried to do that here, and we got y to the 4th over y to the 4th. Well, we know same over same equals 1, right? If we have the same thing over the same thing, that equals 1. But if we do the quotient rule, 4 minus 4 is 0. So this leads to another rule, which we jump to the bottom one, the bottom rule, which is called the zero exponent rule, which just states anything to the 0 power, anything to the 0 power is 1. Okay, so if you see anything to the 0 power, it just means 1. Why? Because when I have the 0 power, that just means I subtracted the same exponent, didn't I? Which means I had the same exponent over the same exponent, which means same over same is 1. And then we go to the negative exponent rule. Okay, I'm going to tell you what the negative exponent rule is. That's what it is. What do you mean, mister? A negative exponent does not mean a negative number. Does not mean a negative number. Write this down. Every time I see someone with, I see a lot, okay, every time we talk about negative exponents, I see a lot of students change it to a negative number. Negative exponent has nothing to do with a negative number. Nothing. Okay, all a negative exponent means is the reciprocal. That's it. That's all it means. It means flip it over. Okay, so a negative exponent means get this thing that's to that exponent and flip it over and then turn it positive. So if I have x to the negative a, so if I have something to the negative exponent, I'm going to, well, let's think about it. X is really x over 1, right? Everything can be written as a fraction. You always got to think about that. Everything can be written as a fraction. So x is really x over 1. So if I flip it, it becomes 1 over x to the a. So now it's positive, right? So if this is over 1, I flip it, and once I flip it, that means this has been done, so I can take it away. Okay, it just means flip it. Okay, so let's see an example. So here I have negative 5, x to the negative 2. Well, negative 5 is fine. Negative 5 is just a number. We don't flip that. That's not an exponent. Negative 5 is just negative 5. That stays the same. But when I look here, x to the negative 2, that's not fine. So I've got to flip it. So that becomes 1 over x squared. Right? So if I put them together, right, this is still over 1. If I put them together, because remember, every number is over 1. If I put them together, I have negative 5 over x squared. The negative 5 stayed where it was. Negative 5 doesn't change. But the x to the negative 2, that has to jump to the denominator. It's basically saying, hey, if you're in the numerator, jump to the denominator. If you're in the denominator, jump to the numerator. Okay, and then let's look at number 2. Let's look at number 2. So 4 over 8, I can simplify that, can't I? I can simplify that. That can be 1 over 2, right? 1/2. And then k to the second over k to the fifth becomes k to the 2 minus 5 if we use the quotient rule. So that becomes 1 over k to the negative 3 over 2. I can't have a negative exponent, so that just means, since it's in the numerator, where does the k go? Good job. Goes to the denominator, k, and then it turns positive, because once you flip it, the negative disappears. Okay, any questions? Any questions? So those are our exponent rules. Oh, one more rule that we had here. Really quick. If I have a product, like two things being multiplied, and I'm raising it to a power, each one of those gets that exponent. So we had negative 2 squared, and we have m to the 5th squared, right? We can separate them and give each one of those terms inside that exponent. Some kids call it distributing. That's not the proper term, but it's kind of what's going on here. But it's not distributing. We're just giving each factor inside there that exponent. So that was one of the other rules we talked about. All right, are there any questions on any of these rules? Because if there's no questions, then we're going to jump to the classwork. But if there are, I want to clear everything up. Zero exponent, yeah, that's the easy one. Zero exponent just it turns to 1. That's the easy one, right? Yeah, someone said I'm confused with the zero exponent. I don't know why. What's confusing you? The 0 or the 1? Because that's all it is. Anything to the 0 power. Anything to the 0 power. It's just the number 1. That's it. No confusion. Should be the easiest one to understand. And if it's not, tell me where your confusion is. And it's okay. Just because it's easy doesn't mean you have to understand it, right? There's been so many times when someone's talked to me like, come on, Mike, this is so easy. And I'm like, wait, I don't get it. I don't understand. Say it again slower. So I get that. Sometimes the easiest ones or the easiest things, sometimes your brain just goes, huh? And then you get to a point where you go, okay. Okay, now I understand what you're talking about. So if the zero exponent's confusing you, let me know. Let me know exactly what's confusing you, because anything to a zero power, if you get a zero power, it just turns, that whole thing turns into one. The exponent doesn't turn into one. The whole thing turns to one. For instance, if I had 3x to the 5th, y to the 7th, all to the zero power, this whole thing is just 1. Okay, no questions. No questions? All right, if there are no questions, then go ahead and start the classwork.